Hey, let's finish up with the rest of the homework problems I want to go over with you. This is from section 4.2a. So number 39, use summation formulas to find the limit of s of n as n approaches infinity. Again, what we want to do is we want to pull the coefficients in front. This will help with the formula substitution step. And another reminder is n is a constant, so we do want to pull the n in front as we're trying to split the problem up into smaller parts. So what we want to do is first step, we want to try to rewrite everything in terms of n. But in order to do that, we first want to isolate the portions of the problem where we're going to be directly substituting in our summation formulas. Okay, so we have our 4 summation formulas here, and we're going to see which one applies, and see if we can isolate the portions that we can substitute in. So I have 16i over n squared. Okay, I'm trying to isolate the I, so the 16 I can pull in front, the n squared I can pull in front as well. Remember, n is a constant, so I'm going to rewrite this as 16 over n squared, and the summation from 1 to n for our quantity I. So we have a specific rule for this, and this is where it helps to have everything FOILed out. Now you could rewrite this as n times n plus 1 all over 2, but eventually you're going to have to FOIL it out, so I have everything FOILed out. Just makes things a little bit faster, so it helps if you memorize this. If you don't memorize it, it's okay. It just means that you do have to do some work for each problem where we're trying to find limit as n approaches infinity. So sigma of I, summation of I is n squared over 2 plus n over 2. Distribute through the 16 over n squared. So we've achieved our first goal of rewriting everything in terms of n. Now we just treat this like how we would finding horizontal asymptotes. We simplify everything down and see if we can find the limit by comparing the degrees of the numerator and denominator. So distribute the 16 through, I get 16n squared over 2n squared, 16n all over 2n squared. Now here the degrees match, so I'm left with, just take the leading coefficient, 16 over 2, which is 8. Here, the degree is higher in the denominator than the numerator. So if we can picture what's happening here, as n approaches infinity, this n squared is going to increase at a much faster rate than the n, and the denominator is going to get larger and larger, a lot faster than the numerator, so eventually this fraction will go to 0. Okay, so anytime your degree is higher in the denominator, then you know that your fraction will go to 0, so that drops to 0. So I'm left with 16 over 2 plus 0, which is 8 over 8 plus 0, which is 8. Okay, next problem, 41. Same step. We want to evaluate the limit as n approaches infinity. So remember, our first step is we want to try to get everything in terms of n. But we need to first clean up the parentheses first. Okay, so I minus 1 quantity squared, I can rewrite this as I squared minus 2i plus 1. I pull the 1 over n cubed in front, and I will distribute that through later. So the sum of I squared, summation of 2i, summation of 1, I can split this up into individual summations. Okay. The 2i, I pull the 2 in front, just so that I can isolate the portions that I'm going to be substituting. So I do have a formula for I squared, which is n cubed over 3 plus n squared over 2 plus n over 6. And you can also think of this as n times n plus 1 times 2n plus 1 all over 6, but I just went ahead and FOILed this out ahead of time, so we can just skip that step. The summation of I is simply n squared over 2 plus n over 2. Summation of 1 is simply n. I still have this 1 over n cubed out here, but so I'm going to go ahead and distribute that through, okay, while also distributing the 2 through as well. So I'm going to do a couple of steps and just put it all into one. But my goal is to try to get all these into separate terms, get rid of the brackets, and distribute the 1 over n cubed through. So I'm left with n cubed over 3n cubed plus n squared plus 2n cubed plus n over 6n cubed minus 2n squared over 2n cubed minus 2n over 2n cubed plus n over n cubed. Now, if you look at all these terms have degrees where the denominator is higher, so we know all these will go to 0. Okay, the only term that's not going to go to 0 is the first fraction, which is going to be n cubed over 3n cubed. We take the leading coefficient, which is 1 over 3, and so that's our limit. All right, finally, 43. I'm going to go ahead and distribute the 2 over n through, get rid of the parentheses to begin with. So I'm left with 2 over n plus 2i over n squared. Split this up into individual summations. So 2 over n times summation of 1, 2 over n squared times summation of I. So I'm just isolating the portions that I'm going to be substituting using summation rules, summation formulas. So the summation of 1 over n from 1 to n for quantity 1 is simply going to be n. The summation from 1 over n of I is simply going to be n squared over 2 plus n over 2. Distribute the coefficients through. So I'm left with 2n over n plus 2n squared over 2n squared plus 2n over 2n squared. My first two fractions will result with the same degrees, numerator and denominator, so I'm going to get a quantity out of that. But here, my third fraction, my denominator is higher, so I know that's going to go to 0. So I'm just take the coefficients for the first two fractions. 2 over 1 is 2. 2 over 2 is 1. So then 2 plus 1 is simply going to be 3.